All right, in this video, I'm going to evaluate this expression and just give you the general idea of how to read summation notation. So that sigma, capital sigma symbol is going to equal sum or mean sum to us. So it's going to mean the operation addition or summation. This little subscript here is going to be referred to as the index. And you'll have usually a starting and an ending number. This tells you to start with the first number in your list and end when you get to the sixth number in your list. So it's a positional thing, right? First number, sixth number. It's not the number 1 and the number 6, right? It doesn't say start with the number 1. It says start with the first value and end with the sixth value. In this case, we only have 6 numbers, so that's our entire list, right? Most of the time in a stats class, you're going to see the top of this says n. N in statistics stands for sample size typically, so we're going to be saying add up all the numbers essentially. Sometimes you'll see that there are no indices given, and that means that they want you to add up everything, right? So it's shorthand or laziness just to say, hey, add all the numbers together. Okay, now I'm saying add the numbers together, but technically this symbol by itself doesn't mean anything. You have to have something in it, right? So summation of x means add all the x's together. If I have the subscript, it just means, same thing, right? Add the x's from the first value to the sixth value there. Okay, now what does this particular one say to do? Well, we're going to have to think of order of operations. Please excuse my dear Aunt Sally. Remember that stuff? So there's basically 4 orders of operation. Multiplication and division are in the same level, and addition and subtraction are the same level. When you encounter those operations, you just handle them as you see them when you read left to right, right? So if you see multiplication first, you would do it first. If you see division first, you would do it before multiplication, right? So whatever comes first in your line of sight as you read left to right is what you do when you come across those two things. However, you always do multiplication or division ahead of addition and subtraction, right? That's the way the order of operation works. If it says parentheses, it means you tackle what's inside the parenthesis first. You apply the order of operations to what's inside the parentheses, and then when you're done with that, you can work again outside of that. But you start with what's inside the parentheses. Here we don't have any parentheses, but we'll look at an example maybe where you do after this. Then you have exponents. E for exponents, you would tackle exponents before you do multiplication or division. Then of course multiplication, division, and then finally addition and subtraction. So let's start with reading what we have here. There are 2 operations implied. We have exponents, right? Because that square there is telling me I need to square the values at some point. That's an exponent. And then we have the summation symbol, but that summation symbol just implies that we add. And again, between exponents and addition, exponents get the priority. So we're going to do exponents first. That means we're going to first apply this exponent to all the data values. That's what it's telling us to do. So we'll have 1 squared, negative 2 squared. Remember, you square the negative with the value 2 as well. Square the 10, square the 3, square the negative 4, and then square the negative 3. Okay, so if we square those values, we get 1, we get 4, we get 100, we get 9, 16, and then positive 9. And only after we've done all the squaring do we apply the addition, right? So we've done the exponents, we're down to the addition now, so now we tackle the addition step. So we just add at that point. And there you have it, so 1 and 4. All right, I was gonna leave out the summation part because I figured that'd be easy, but then I thought better of it, so let's go ahead and do this together. 1 and 9 will make 10. 4 and 16 make 20, right? And then we have 109. And then, of course, this makes 130 plus 9, or 139. So that's the sum that you get when you finish the problem. So what happens if you had something very similar to this, but the parenthesis was surrounding the summation symbol in the x, and the exponent was outside of the parentheses? What would happen then? Well, here you're saying basically that we have 3 orders of operations being represented. The parenthesis is the first order. Then we have the exponent over here, right? That exponent is the second order. And then inside the parenthesis, we have summation, right? Or addition. So the question is, how do we tackle or handle these things? Well, normally addition would go last. However, the parenthesis preempts that, right? So the parenthesis says, hey, do what's inside the parenthesis first. Work out what's inside here. Ignore the exponent that's outside of the parentheses. Ignore anything outside the parentheses and just tackle what's inside the parentheses. If we just look at that, they're saying, hey, we need to sum up all the x values. And if we do that, it's 1 plus negative 2 plus 10 plus 3 plus negative 4 plus negative 3. So here the positive 3 and the negative 3 would cancel out. We'd have 11, in other words, the 1 and the 10 make 11, and then negative 2 and negative 4 make negative 6. And so the end of that is going to be 5, right? So the answer becomes 5 when you add up all the values. And then all we have to do is to put that in place of what we see there, right? So this whole inside piece is just 5, so we'll have 5 squared, right? And then 5 squared is just 25. So we do the exponents last in this case because the parentheses preempt the exponent operation and tell us do the summation first this time. So we get 25, a very different answer, right? And how do we make these decisions? We always refer back to the order of operations. So when you read the notation, always think what operations are being implied, which one would go first according to the order of operations.